Today we're going over factoring higher order polynomials. So these will be polynomials with a exponent higher than 3, so 4 or more. But first we're going to talk about difference of squares. And this is going to be when two perfect squares are being subtracted. So let's look at x plus 9 times x minus 9. So we have x and 9, but the first parentheses is adding and the second parentheses is subtracting. If we FOIL this, we end up with x squared minus 9x plus 9x minus 81. And then with negative 9x and positive 9x, that is going to eliminate the middle term. So now we just have x squared minus 81. Let's look at another one. We have 5x minus 7 times 5x plus 7. So that would give us 25x squared plus 35x minus 35x plus, minus 49. And again, these middle terms are going to cancel out. So you end up with 25x squared minus 49. One last example. This one would give us 4a squared minus 6ab plus 6ab minus 9b squared. Same thing happens with the middle term. And we have 4a squared minus 9b squared. So what does that mean when we're factoring? So if we have a and b, and we have one binomial that's being subtracted, one binomial that's being added with the same terms, the answer you will get will be a squared minus b squared. And remember, factoring is just the reverse of that. When you're factoring a squared minus b squared, you would take the square root of each of these terms. The square root of a squared is a. The square root of b squared is b. And then you're going to put these into two sets of parentheses. 1 plus, 1 minus. The order of that does not matter. But you'll have a plus b times a minus b. And that's how you factor a difference of squares. It's mainly being able to recognize the pattern and know how to break it up. So this does not work for a sum of squares, only subtraction. So let's look at a couple of examples for just difference of squares before we go on to higher order. We have x squared minus 64. So I'm going to take the square root of x squared and the square root of 64. The square root of x squared is x. square root of 64 is 8. So my answer will be x minus 8 times x plus 8. All right, 16x squared minus 121. You need to be able to recognize when you see a perfect square, so a number that has a perfect square root. So get familiar with those perfect square numbers. But the square root of 16x squared is going to be 4x, and the square root of 121 is 11. So we're going to have 4x plus 11 times 4x minus 11. Let's go to factoring higher order polynomials. So remember, when you're factoring, you always want to look for a greatest common factor first. And I can see that I can factor out 9x. That leaves me with x to the power of 4 minus 16. Now, I need to see that and recognize that that is a difference of squares. So, what's the square root of x to the power of 4? That would be x squared. And the square root of 16 is 4. So I have x squared plus 4 times x squared minus 4. Now don't forget to bring down this 9x. And then, hopefully you've noticed that there is another difference of squares here. So we have the square root of x squared, which is x, and the square root of 4, which is 2. And again, you can have subtraction first and then addition second. It doesn't matter which order they're in. This one just comes down, and this comes down. So this is my final factored polynomial. So you'll know you're done when nothing can be factored any further. Let's do an example of a trinomial. Okay, so with a trinomial, we still have to solve the x puzzle. So we have negative 15 on top, 14 on the bottom. This is going to be positive 15 and negative 1. Now, when you rewrite this as a 4-term, you need to make sure that you're using x squared. So whatever the middle term is what you're using. So we have 15x squared minus 1x squared. So you'll see here, this tells you what you're going to be using when you break up those numbers. And then we'll bring down, oops, minus 5 and 3x to the power of 4. Now we factor by grouping. So I can factor out 3x squared. And that leaves me with x squared plus 5. And then we'll factor out negative 1. X squared plus 5. And before you're done, always make sure that you don't have a difference of squares before you decide that you're completed and you're moving on. So this does not have a difference of squares. Let's do one more example. Now these numbers are kind of big, especially that 315. So that's one hint that you're going to have a greatest common factor that you need to factor out from all the terms. So always try the smallest one to begin with. We can factor out 5. Now I have a trinomial. And a is equal to 1, so I can use the shortcut. So I have negative 63 and negative 2. So that means I can use negative 9 and positive 7, and I don't need to factor by grouping, but I do need to remember to use x squared because that's the middle term here. Bring down the 5, and now we have a difference of squares. X squared minus 9 can be broken down to x and 3. Oops, that should be a plus. Okay, and then we still have x plus 7 and 5. So just make sure you're keeping all the parts to it and you're not leaving anything out. Oh, this, I apologize, that should be x squared. Okay, so that's what you'll be doing in today's practice. Main thing is that you need to make sure that you recognize when you see two perfect squares being subtracted and know how to break that down in the pattern of a difference of squares.